All right, welcome to video 2. Let's take a look at cell references, basic formulas, and some error handling. Cell references. Let's start by how do we point to things in Excel. I'm going to get rid of some of my previous work because I'm already giving you the answers. All right. The most basic way that Excel operates is by these relative references. It is putting in a formula to point to another cell. So you can see here in cell C6 that I'm pointing to cell F6. And if you look over at F6, it is highlighted in blue. That is telling you just these two things are connected. So whatever is in cell F6 is going to show up here in C6. The reason they call this a relative reference is if I were to copy this and paste it in the next cell down, it will increment that reference by 1. And so it'll change it from equals cell F6 to equals cell F7. I moved it down 1 row, and the reference changes by 1 row from 6 to 7. That's the relative part of that name, the relative reference. So whether I copy it down or I use the autofill function, which is this little square here, you can double click or click and drag it. Now all of these are incrementing by 1 and pointing to the values over to the right. That's your basic type of referencing in Excel. It is called a relative reference. Now there's times that you need to do something different. So let's look at a couple of those. This other type of reference is called an absolute reference. There's also a mixed version of this. But the absolute reference is locking in your reference so that when you move your equation by copying it and pasting it or dragging down that autofill option, you don't change where it is referencing. Now here I've put it in an example that is similar to something I have to do, on a daily basis, is some sort of simple modeling that references like a growth rate. So we've got an example here where in 2020 we had a patient volume of 10,000 patients, and we want to know what will that volume be if it grows by 3%. So when we enter that, we get the proper answer. Now, you're going to notice something different about how this equation is written and how those cell references look compared to what we looked at before. The second cell reference pointing to the growth rate has a $sign around it. That is because I want that 3% to always be what's used in this equation as it continues down. So if I were to copy and paste it into the rest of my table, even at the very bottom, it is still pointing to C16. And that $sign is the thing that locks it in. Now the $sign you can type in there, but also the shortcut is to hit F4. So if I hit F4, it's going to change this to a slightly different type of reference that we'll look at next. Change it again, it changes, hit it, now no $signs. But if I hit it that first time, once I'm clicked on a cell range, it puts a $sign in front of each. Now that is an absolute reference. It will always point only to that cell. And that's what I needed here. But just to make it abundantly clear why that's needed, if I were to not have those $signs in my equation, as I copy it down, that reference will increment. You see now it's pointing to the wrong area. So that's the reason that we're doing that sort of absolute reference. You saw when I hit F4 that it had a couple different versions of the $sign. One where the $sign was in front of both the column and the row, one where it was just the row, one where it was just the column. So here I've got an equation where that comes in handy. The example I've got is that we've got a range of patient volumes, and we have a range of possible lengths of stay. Now this comes up in my day-to-day and is a good pro tip. When you're given a simple question, don't always provide a simple answer. You may be asked a question like, what do we expect the patient days to be this next year, this next quarter, whatever the case may be? And of course, you can make an assumption like, yeah, I think that our patient days are going to be similar to whatever our volume is now, which is 2,300 patients, and we'll multiply that by the length of stay, which is how you get patient days, which represents just the total days that patients stayed in the hospital, and you get your answer. So you can take that back and give that answer, but it's also very easy to challenge those assumptions. Someone may say, yeah, we're not going to have as much patient volume, or why do you think length of stay will stay exactly the same? It's very likely to increase, decrease, whatever their is in their head as what's going to happen is an easy thing they can use to attack your assumptions. But here's a way to get around that. Provide them a range of possible values. So you may do that by saying, I think our patient volume will be somewhere between 2,000 and 2,500 patients, and our length of stay is unlikely to go under 5 days. It's also unlikely to go over 8.5 days. And so, great, now we've got an equation. We are just going to go ahead and take each of those things times each other. All right, all set. Nope. I've done that naive mistake again, just to point out the example that if I keep the reference, if I make that reference relative, that it will always change whenever I put this equation somewhere else. And so we need this ability to do a mixed reference. All right, so let's start at the upper right-hand corner and think about what we need here. We need to point to the patient volume, and we always need to point right here to this row. Now that's your indication. I don't want this to ever change to a different row, like row 32 or 33, but I do want it to change over to the next column as I move this. So I'll hit F4 until I have a $sign only in front of the row. I've hit it twice. Now there's a $sign in front of 31 there, and that should be locked in the way that I need it to. The way I can check that is by copying and pasting it through the rest of the table. And now you see that as we move over a column, we get the next column's value for patient volume, but as we move down a row, we do not change that value. So that's what we needed. Now the other part of this equation is simply to multiply it by the length of stay. In this top left corner, we're multiplying it by the 5-day length of stay, but we need to lock this in some way. As you might have guessed, it's kind of the opposite. We need this to increment whenever we change the row, but as we move across the columns, we don't want this to keep coming over a column. We want it to stay right there. So we're going to hit F4 on this until we have a $sign only in front of the column. Just 3 times. So we have $B 34. Now we've got our answer. Now when I copy this across my table, we've got something that you can tell looks about right. So this would enable you to give an answer more like, it's very likely that our patient days will be around 16,000. However, if we experienced a very big drop in volume and a lower length of stay, we might have as few as 10,000. Or the other end of that spectrum, we might have a very high, like 21,000. So you probably would say that the most likely range is somewhere between 13,000 and 18,000. That just helps give a better answer even when the question is somewhat simple. So it's a meaningful example, and it shows you how to use mixed references. So I've already kind of given you the why it matters in healthcare, that you need to sometimes use some reference value to point to, and you want that to stay the same as you move your equation. All right, let's head back to the index and look at what item number 2 is. Item number 2 is our basic arithmetic formulas. So we're going to start with the most simple math. We've got value 1 and value 2, and we have 3 different mathematical operations going on. We've got value 1 plus value 2. We've got value 1 minus value 2, and value 1 divided by value 2. And so the only thing that changes in the middle is the operator. They're all pretty common sense. Plus is plus, subtraction is a dash, but let me show you one that might be less clear. Multiplication. I'm going to use the same values. Multiplication is actually done with an asterisk. So I just like to show that to beginners because it's not as obvious, and it's also something you could figure out, but quickly now you've seen it from me. All right, that's multiplication. Now let's look at some healthcare examples of how this might be used in a relatively simple way. Also, I'll expand so you can see another example of how the same operator can do something different with a different data type. So here's a really simple record where we have the same patient, because they have the same patient medical record number. They've got the same date of birth, because you're only born once. And we've got a date of service, so dates where we had provided a service to them, either in the hospital or the clinic. And so we could calculate their age by taking the difference between this date of service and their date of birth and dividing by 365. Now I'm doing something now, however, that you may not have realized we needed to do. This equation here will operate just like you probably learned in middle school with the PEMDAS principle, that the first things to be calculated in an equation are first parentheses, multiplication, so on and so forth. And so in that, if I were to leave my parentheses out and just do E17 minus D17 divided by 365, the first thing it's going to do is D17 divided by 365. Then it'll do a minus. And so you'll get an answer that doesn't make any sense. They were 44,000 years old when we helped them out. Not the case. But if I get my parentheses in the right place, the first thing that's going to happen is it's going to look for the date of service minus the date of birth, returning the number of days between when we helped them and when they were born, divided by 365, so we get their age. And there we have 37 years old for this first encounter. They were 38 for the second, 40 years old for the last. So there's an example where I've used both the minus operator to subtract two dates from each other, and the divide operator to divide by 365. But I've also used parentheses to properly get this to do the math the way that I need to for my use case. So that's how our mathematical functions work in Excel. I've got one more example here. I've pre-calculated a bit of it. I'll get rid of that just to show you the type of thing that may come up in my work. So here I've got a bunch of different encounters with different patients. I've got the primary diagnosis, which is indicated by the ICD-10. It is a type of code that represents a diagnosis. I've got the date they were admitted and discharged, and I've got an average daily cost, presumably for that diagnosis. And so this would be used for some sort of modeling or forward-looking information where we don't have the finances yet. We don't know how much this patient or this encounter costed, but we can presume it from what we know about the past. We know that this ICD-10 of E11.9 has an average daily cost of $155. We know the patient's length of stay, and I've actually calculated that by taking the discharge date minus the admission date. They're here 7 days, and so if you multiply those very simply, you get the expected total cost for that one patient. And we can continue this down through the rest of the table to see how long each of these patients were here, and based on their primary diagnosis, what's our expected cost for each of them. So that's an example of how you might use some pretty basic math to accomplish something you need to do, like some simple modeling of cost. All right, that's what we got on the basics for arithmetic formulas. Let's head back and look at number 3, basic functions. So this is going beyond math and starting to use functions. And so I'm going to start with the really simple stuff, which is a sum. The sum is just adding up everything. And so we're going to do the sum of a range. We're going to use a function that I know the name of. You may not know the name of. It is sum, or SUM. So I'm going to type in equals, and I'm going to start typing sum because I know what it's named. And look, Excel is trying to help me. It shows me all the different equations that start with SU. And of course, you can see one of them is sum. It also tells you when I use the arrow keys to navigate to that, what it does. It adds up all the numbers in this range of cells. That is what I'm looking for. I'm going to hit tab because I know that's the shortcut to complete the formula name and to open up the parentheses to start inputting things into the formula. And now I need to sum something. I need to point out what it is that I want to sum. So I'm going to show you first the most manual version of this. That would be to type out the range. I'm going to sum the build amount above, and so I'll say equals to sum of I7. I'll put in a colon and say through I18. This would be the way that you reference a range of cells in Excel. And you can see up above that it's showing you visually where is that range that you're referencing. And so now it's going to take all those values and add them up, and we have an answer. Now the primary way that Excel is used, even though you can type it in manually, is to do more of a point and click type of operation. So if I say equals sum again, and I just point and click to the range that I want to measure, it's going to enter that range into the equation. But this looks strange, right? We've actually got, sorry, I'm just going to close this and finish it. We've actually got something different. We don't have a cell range based on a column and a row. We've got something that says inc and billing amount. That is because what's up above is a table. We'll talk about that in later examples, but when you're using tables, it uses the table name and the column name from the table as a way to reference those cells. Now this can be quite handy and make the statement read a little more common sense. And so this says, give me the sum of the encounter table and the billing amount column. And there we get the same answer. All right, let's try average. I'm going to show both the manual and the more automatic version. From there on, we'll just do the automatic because that's the primary way people work. I happen to know that average is referred to in this way. It's just the word average. So I start to type that and I see it there as an option. If you don't know the equation, you can click up here, this little function button, and it will pop up. Since I already have a function entered, it's going to just tell me what to do for that particular function. But when I get out of that and I don't have a particular function there, I can crop this up and say look for all functions, and I can look through all of them until I find what I need. In the example that I was looking for average, I would find it here once I scroll down to that area. When I click on it, it tells me what that function does and what gets input into the function. So that's a way to look things up. Another great way to look it up is Google, YouTube, all those simple things. But I know it's called average, so I start typing that, hit tab to complete it, and now I need to reference that range. So I say I7 through I18, close that up, and now I've got an average of those instead of the sum of them. And so the automatic version is equals average, and point to that range. You can see it fills in the table name and column. Close it and hit enter. We've got the same result. One's just a little bit easier. All right, so I'm going to show you two more simple functions, make that 3. The first is the min. It will tell you within a range what's the minimum value. So it is just min. If you're doing max, it's max. Pretty easy to intuit, but the first time may be hard to find the exact function you need. Here I need the minimum, or min, of that range. And so I'm going to go ahead and do the quick version, point to that range, and hit enter. And now I've got the minimum, 6,185. That is the smallest value that is up here in the range, right there. So it's found that automatically for me. All right, let's look at two more. The first is called count A. Now there's a number of count functions. They've got different purposes and different ways that they can count. Count A is used when you want to count all of the non-empty cells. This comes up in especially data sets that have maybe missing information or blank cells. But there's a number of count options that you can explore and get familiar with. This count A is counting all of the non-empty cells. And so we complete that, and we've got a count of 12. There we go. There's 12 different items in that table. Now we've got a COUNTIF. This is just one more variation on the count function. This is going to do kind of like it sounds. It's going to count a range if a criteria is met. And so the two items that go in are a range and a criteria. So the range is going to stay the same. I actually want to, I take that back. I'm going to do a different example. We are going to count a different column in the table, the insurance provider. So I'm going to point and click to that. And of course, the formula gets filled out as I need to. It's got a COUNTIF of this encounter table and the insurance provider column. But now I need to give it a criteria. I want to go ahead and put in the criteria of Medicare. I want to see how often, please count every time that this column comes up as Medicare. So I can see how many Medicare patients we served. And you're going to see that I put the quotations around it. So that's necessary whenever we are using text within a formula. So I hit enter and I get 4. So there's 12 total records, 4 of them were Medicare patients. So those are some of the examples and how they come up as meaningful in healthcare, like taking the count of a specific insurance provider, finding out the minimum amount that we charge, the average, and the total. All right, let's head back and look at the next item. We've looked at basic functions. We are headed to error handling. All right, here on error handling, I've got a number of different errors. I have actually done some pre-work and gotten rid of them, so I'm going to have to remake a few of the errors for you. All right, so yep. I'm going to get rid of this one. Sorry, you're seeing a little bit of how the sausage is made, but maybe it'll help you in the long run. We'll see. All right, so now we've got a couple different types of errors. We're using a formula you'll become very familiar with because I'll share a lot with you about it in a later class, the VLOOKUP formula. And so here, the first type of error is a value not available. The VLOOKUP formula is looking something up. This value right here, you can see that the first item in there is a lookup value. It's pointing to C41. There's nothing there. So that is the error that's happening. That is why we have this NA error. Now, if you don't know what's going on with the error, there's a couple of tactics. Number one is to take a look into this error messaging that's available, and it'll tell you a little bit more about what the name of the error is. Another really useful thing is a help on this error. It opens up a help window right here within Excel and has some resources on what is this error, what are some common causes, and what might you do to troubleshoot and find out how to fix it. So that's very useful, but usually it's just a careful examination of what was I trying to do with this function and where might it not have the information it needs. In this example, it doesn't have a value to look up, so that's what's going on there. This next one is an invalid name. And so let's figure out why this might be happening. We've got it looking at Chad Beard here. It is looking it up in this table above. And then these two items, I don't need to give you all the context, but they are proper. It needs a number here and it needs a true or false here, so that looks good. If you look really close though, I've got an extra P in the name of this function. That's all that was going on. Another little hint you might have had is as I was moving my pointer through the function, I wasn't getting the typical pop-ups to say, hey, this is the section of the function where you put the table array. That is because I had it spelled wrong. So that's the type of error that can pop up, and it would be called invalid name. Just one example. All right, now we're going to look at a null error, and actually, I think I've got this set up wrong. All right, now we've got a null error. So we've got VLOOKUP spelled right, and it's giving us the hints of what goes in VLOOKUP, so that looks good. We've got a lookup value, and it's for Chad again. Looks good. Then we got this range, this lookup table array, and it's pointing to two separate cells, not a range. So that's the error that's going on. We've got a need to have a table array, a range, and we don't have it. And that is because we're missing a colon. So a range is referred to by putting a colon between the top left and bottom right edges of that area that you're looking for. And now we got that working. All right, finally we've got invalid name again. This one is same equation. We're looking up Antonio here. Let's make sure Antonio's up here. Yep, he is. Oh, and now we've got our little hint as to what might be going on. Name error there, and if you remember, this was a name error here. And so what's going on is it's looking up Antonio in this table, and it is returning the second value, which is column number 2 here, and it has an error. So it is simply returning an error. The function essentially written correctly, but it's got bad information above. So there are a couple of common examples of errors that happen, and you can see my process for looking for the errors. I'm evaluating the function to see if it's got what it needs, it's pointing to relevant and appropriate ranges, and it's got the other items that it needs to just try and troubleshoot and figure out where the error may be. For the most part, fixing and avoiding errors just comes from checking your references, making sure it's pointing at the right thing. If error will go over in another session, and ensuring that you've got correct data types. Those three things, for the most part, will help you fix or avoid your common errors. And if you're really stuck, YouTube and Google are the ones who have helped me learn pretty much everything I have. So, all right, that's class number 2. Can't wait to see you for class number 3.